Hello everyone, to the next session, a new concept, a new day. We are done with creating a forecast, understanding what the future prediction is. According to that forecast, choosing a location. According to the location, choosing the layout of the facility. According to the layout of the facility, making an aggregate plan. And on the basis of the aggregate plan, the last concept that we did is understanding what the required capacity is and how are we going to meet that required capacity. When we were doing capacity, we realized that more often than always, your plant or your system doesn't run 100% to capacity. It falls short a lot of times. And that is where productivity or efficiency or utilization comes into picture. After productivity, efficiency or utilization, we come to the next concept, and that is sequencing. What do you mean by sequencing? Well, by sequencing we mean that when you get a job, how do you sequence it? For example, you are a pipe manufacturer. If you are a pipe manufacturer where you make PVC pipes, now I don't know if you all know how PVC pipes are made, but I'll give you a basic gist. There is a raw material which is polyballs, which is basically your polyethylene, if I'm correct. These polyballs are these are very small plastic balls. That is basically plastic in the most virgin form, in the most raw form. This goes into a machine. That machine looks like a flour mill. Like we have flour mills where we do wheat flour or rice flour, wherever. Same, it's almost the same. You put the raw material in, the machine heats up the raw material, it liquefies it, and then gives it whatever shape it requires to get. So if you are making a pipe, you will see a pipe being made outside. So if you are a pipe manufacturer, when you get orders, how do you sequence it? Now I do know this for a fact because my uncle here in Kolhapur has a small plant where he makes PVC pipes. So this is how he sequences it. Now everybody's sequencing technique could be different. This is how he sequences it. Setting up or tuning the machine is painful. Every time you want to change the diameter of the pipe, every time you want to change the thickness of the pipe, there's a lot of settings that goes on. And after the settings are done, there is a lot of trial and error to check if the desired specifications are met or not. By constantly counting, is it correct? Yes, if you have a fully automated machine, nothing like it. But when you have a semi-automated machine where you have to do all the settings, it becomes difficult to change the settings over and over again. So what he does is, once he has orders, he marks the orders that are similar in specifications. And all the orders that are similar in specifications are done together. Why? Because it is easier to process all of them together, less wastage of time, less trial and error, and less changing of settings. But it is not always that everybody sequences in that manner. Whenever jobs come to you for processing, everybody sequences them in different ways. Let's take examples. If at all you go to a doctor with an appointment, then you take an appointment and you go meet the doctor. But the doctor will give you a specific time to come. But if this is one of your local doctors who basically before you tell him also what you are going through, he's already told the compounder what tablets to fix you, and the compounder has already made a packet before you can even complete what you had to say, and then all you pay is 20 or 40 bucks and you leave. These are the kind of doctors that I'm talking about. Here you don't take an appointment and you go. Here you go, you sit in the queue, and then as and how the queue proceeds, you get your turn. And that is called a first come, first serve basis. So my job in that case is sequenced in the first come, first serve basis, also known as FCFS. It is also known as FIFO, first in, first out. This is also what your brain works on. If your brain has, let's say, a 1 year memory, now I'm just giving you an example. If your brain has a 1 year memory, whatever you read once today, 1 year ago, will stay in your brain. After tomorrow, it will go out unless it is revised and brought back and revived in the chart. First come, first serve basis. Whatever comes first gets processed first, or whoever comes in first goes out first. First in, first out, FIFO. But there are times where you don't use FCFS, but you use LCFS. What is LCFS? Or also known as LIFO. LIFO is last come, first serve. What? Anybody who comes last will be served first? Yes. How come? I'll give you an example. Suppose you are loading a truck. Okay. Now, if you are loading a truck, let's say I'm giving you a basic idea, and this is the top view of the truck base where I'm loading stuff. Now, a person walks in and he starts putting the boxes, starts piling them one on top of the other. And this is how it's happened now. Now, whenever I'm offloading the truck, this is where I will start offloading from. So, whatever box was put in last is going to be pulled out first. So, this basically happens in cargo. This happens in cargo where anybody who has gone in last, or anybody's luggage that has gone in last, will come out first. Is also known as last come first serve or LIFO. While some prefer something else. Now see, this is not preferred. It automatically happens that way. So sometimes you plan it, sometimes you don't plan it. Like FCFS is not planned. There is a queue, come and sit, I will attend to people as and how they come. Last in first serve, here is not planned. You started loading the cargo, or imagine you are putting boxes in a room. You fill up the room with boxes. Now when you want to remove those boxes, whatever box you see in front, which was the last box that you put, will come out first. Well, you could also have something called as SPT. What do you mean by SPT? SPT means shortest processing time first. Well, what does that mean? Suppose you go to a Xerox center and the guy is Xeroxing an entire book. Now we've all done this. There is that one Xerox guy outside college where we've always stood for your notes that you were getting Xerox for some paper, and you always wonder, ये कमाता कितना होगा? अगर मेरा कुछ नहीं हुआ तो मैं एक Xerox center तो definitely डालूंगा, बहुत चलेगा. This will change once you start working. Once you start working, you come out of office for a tea break and you are like, ये best business है. मैं चाय के डब्बे डालूंगा. And then don't tell anybody I said it, but chai with cigarette is like the best combination, because whenever you walk out of corporate parks, all you see is people having tea and cigarettes. So you're like, yahi dukaan hai apni. Chai, cigarette, business, boom, I am the next Ambani. We've all been there. So let's say you go to a Xerox center where the guy is Xeroxing an entire book. And you can evidently see that you are on the 5th or the 6th. He is like a 50 or 60% into the book. Now there's still 40% of the book left. What have you gone for? One Aadhaar card. One Aadhaar card that I need 2 copies of. So if he is me, he will say, nahi hoga, jao. Obviously, I'm not going to stop this work for like 2 copies. But then if he's a nice person, what he will do is, he will stop the book. He will give you the Aadhaar card copy. And then he will start with the book first. So what did he do? Whatever is the shortest, see, just one Aadhaar card, no? It will hardly take like 15 seconds. The shortest article is processed first, or the article with the shortest processing time is processed first. Similarly, you have LPT, which is longest processing time. What is longest processing time? Orders come in, you say, arey, this is going to take a lot of time, huh? Process this first. Because later it will take a lot of time. So process that now, and then small jobs you do later is longest processing time. Sometimes you also process according to a strategy called EDD. What do you mean by EDD? EDD is earliest due date. What is earliest due date? Whatever article is due earliest, process that first. I don't care when it's come. I don't care what the processing time is. All I care about it, when is the due date. Whoever's due date is the first will be processed first. Now, luckily for you, you don't have to decide what your sequencing technique should be. All you have to do is they will give you the sequencing technique and you have to apply it. That's it. So that is what we are going to do. Jobs will be given to us and we will be asked to process with different criterias, and we have to tell them the different ways of processing the jobs. Let's come to questions then. So the first question I'm not going to do right now. Skip it. Let's start from question number 2. The question says, table shows the time remaining, which is number of days until due date. So what does it show? In how many days is the date due? Sorry. And the work remaining, which is the number of days still work remaining to finish the job. So this first column tells you in how many days the job is due, and this tells you how many days worth of work is still remaining. For the 5 jobs which are assigned the letters A to E as they arrived to the shop. So this A to E is as they arrived to the shop. So as and how the jobs arrived to the shop, I gave them names A to E. Sequence these jobs by priority rules, namely FCFS, which is first come first serve, EDD, which is earliest due date, LS, which is something called as least slack. I will tell you what that is. SPT, which is shortest processing time, and LPT is the longest processing time. So this is what I'm going to do. I'm going to write the table down so that we can refer to it whenever we want to, and then start the question. So let me quickly write down the table. I have the table ready. Let's start with the question. So what I have done is, so that I don't waste place, I have written down the table horizontally. You can write it down vertically so that my entire thing fits on one page. That is what is important to me, so that I don't have to keep turning behind. Anyway, starting off with number 1, FCFS. What is FCFS? First come first serve. Or if it is first come first serve, then there is no choice. The answer is A, B, C, D, E. That is how I am going to process all my 5 jobs. As they come, I will process it. A, B, C, D, E. Option B is according to EDD. What is EDD? Earliest due date. So, A is due in 8 days, B is due in 3 days, C is due in 7 days, D is due in 9 days, and E is due in 6 days. Whose due date is at the earliest? Well, B's due date is at the earliest. After B, whose due date is the earliest? Well, after 3, the next job is E, which is due in 6 days. After E, the next job is C, which is due in 7 days. After B, E, and C, the next job is A, which is due in 8 days. And then after that, the last job is D, because D is due in 9 days. That is B. Let's come to C. What is C? C is something called as least slack. Now, before I begin with least slack, let me first tell you what does least slack mean. Now, you must have read this somewhere, or you must have heard this saying, stop slacking around. What do you mean by stop slacking around? Stop slacking means stop wasting time. So basically, with least slack, we are going to find out how much time can we afford to waste. How much time do we have that we can waste. Like for example, I am going to find the slack of. Again, I am doing a horizontal table because I don't want to waste place. You can do a vertical table. A, B, C, D, E. I am going to find the slack for every job. How? A is due in 8 days and the work remaining is only for 7 days. Can I say I have 1 day of slack or 1 day that I can still waste around? Yes. B is due in 3 days and work remaining is 4 days. 1 minute. So it is due in 3 days, which means in 3 days the job has to go. But the job has 4 days still processing remaining. Can I say there is no time to slack? I forget time to slack. I am already 1 day short. Because I only have 3 days to do the job and the job is worth 4 days. So isn't it a negative 1 day slack? So what am I doing? I am basically doing a due date minus work remaining. The due is 7 days, work remaining is 5. I can slack for 2 days. The due is in 9 days, work remaining is only 2 days. I can slack for 7 days. Due is in 6 days. I have 6 days worth remaining. 0. Now, whichever job has a less slack becomes important. So according to the least slack rule, I will say that job B has the least slack. That is why I will process that first. After B, E has 0 slack. So that I will process second. After E, then there is A. A still has 1 day to waste. So that will come third. After that comes C because C has 2 days to waste. And after that comes D because D has 7 days to waste. So if you ask me, according to the least slack rule, this is going to be my sequence B, E, A, C, D. That was the third one, which is least slack. Let's come to the fourth one, which is SPT. What do you mean by SPT? SPT is shortest processing time first. Whoever's processing time is the least will be processed first. So let's come back. Let's look at the processing times that are remaining. In this, whoever's processing time is the least will be processed first. Whose processing time is the least? D. So D will be processed first. After D, the next least is B. So B will be processed first. After B, C. After C, E. And after E, A. So according to SPT, which is the shortest processing time first, my sequence is going to be of the type D, B, C, E, A. And let's come to the last E, which is the longest processing time first, or LPT. Now if SPT is D, B, C, E, A, which is in an ascending order of processing time, then LPT will be in a descending order. So reverse, just write down A, E, C, B, D is going to be your answer. And this is it. FCFS, first come first serve. EDD, earliest due date. LS, least slack. What do you mean by slack? How much days do I still have floating or extra? How do you find that? It is the due date minus the work remaining. Then I have the shortest processing time and then I have the longest processing time. Let me quickly look at the solution. So let's come to one thing at a time. Again, please write down whatever they have written so that it becomes easier for you to write it down in the exam. Make a proper running solution of everything. So let's come to the first one, FCFS. First come, first served. Since the jobs are assigned letters A to E as they have arrived to the shop, The sequence according to FCFS priority rule is A, B, C, D, E. So as of now it is A, B, C, D, E. Let's come to the next one, and that is EDD, earliest due date. What does that mean? Taking into account the number of days until due date, the sequence of the jobs as per EDD is BECAD. They have written the due dates also. If you want, you can also write down the due dates. BECAD. Let's move to the next, and that is LS, least slack. Now I don't think I will be able to show you least slack here, so let me show you least slack full. Now what they have done for least slack is they have found the slack. So their slacks are 1 minus 1 2 7 0, correct? Let's check our slacks. Is it 1 minus 1 2 7 0? Our slacks are 1 minus 1 2 7 0. Perfect. How do they do that? Slack is number of days until due date minus the number of days that work is pending. Okay. What is your sequence according to that? It is BEACD, BEACD. Perfect. Next is D, shortest processing time. Shortest processing time is DBCEA, DBCEA, and longest processing time will be the exact reverse, and that is AECBD, AECBD. And that's going to be your answer. Now see, this is not accounts or this is not a cost sheet where you have to show it in a certain pattern only. So my job is to tell you the concept. If the presentation in the material is good, then stick to the material presentation. There's nothing wrong with it. Basically, you have to explain everything in as much detail as possible, because tomorrow, if they ask you this question for 8 marks or 10 marks, which they do by the way, if they ask you this for 10 marks, I can't give you 10 marks for this. So what will you do? You'll try to make this as colorful as possible. By colorful, I don't mean use multicolored pen. What I mean is explain everything to them. What does FCFS mean? FCFS is first come, first serve basis. The job that arrives to the shop first will be processed first, which is basically what they have also done, or which is basically whatever I have kept saying, but I didn't write it down. I would expect you to write it down so that the teacher looks at it and she knows that yes, the answers are there, but there's an explanation also, so I can give him or her all full marks. That was question number 2. Let's come to question number 3. Let's come to the next question. The following jobs have to be shipped a week from now. Week has 5 working days. So I know our week has 7 days, but their working week is only 5 days. 2 days is an off. So when they say that the jobs have to be shipped, you mean every job has to be shipped. By when? In the next 5 days. Okay. What is it that you want me to do? Job A to F, number of days work remaining. So they have given you how much of work is remaining. What do they want you to do? They want you to sequence this according to priority A, least slack rule, which we just did, and priority B, which is the critical ratio rule, also known as CRR. Okay. So one thing at a time again. Let me do one thing. Let me first write down the data. Okay. So this is the question. The question is jobs A to F and the work remaining. Okay. What else? Well, I know that all the jobs are due in the next 5 days. So due days for everyone is 5, 5, 5, 5, 5 and 5. So if you want me to sequence this according to LS, which is the least slack rule, I need to find the slack. How will I find the slack? Well, slack is easy. Slack is the difference between the due days and the work remaining. Basically, how many days extra do I have to waste? So slack is due days minus work remaining. The job is due in 5 days and the work remaining is for 2 days, which means I still have 3 days to slack. Job is due in 5, work remaining is 4 days, 1 day to slack. Job is due in 5 days and the work pending is for 7 days. I am already a negative 2 days. I am already 2 days short. So even if I start today, there will still be 2 days worth work pending. -1, 0 and 2. If you want me to slack, or if you want me to sequence according to the least slack rule, the least slack of all is the -2. So C. After the C will be the D, which is -1. After D will be E, which is 0. After E will be B, which is 1. After B will be F, which is 2. And after F will be A, which is 3. And that's your sequence: C, D, E, B, F, A. Let's quickly look at if that is what they have in their solution also. So let me do a thing. Let me pull out the bigger solution. So they have also calculated slack, and their slack is 3, 1, -2, -1, 0, 2. 3, 1, -1, -2, 3, 1, -2, -1, 0, 2. Let's check. 3, 1, -2, -1, 0, 2. Perfect. So sequence should also be the same. Their sequence is C, D, E, B, F, A. So let's check my sequence. Is it C, D, E, B, F, A? Perfect. So the answer is correct. Let's come to the second, and that is they want you to sequence the jobs according to the critical ratio rule. Now what is critical ratio? Well, critical ratio is nothing else but slack. If you've done math at the foundation level, then, and if you've done math with me, I must have told you something like AP and GP are similars. Whatever you do in AP, you do the same in GP. The only difference is in AP addition becomes multiplication in GP. In AP subtraction becomes division in GP. So same. I am again going to calculate the slack only, but with a slightly different rule. And the rule is, I am not going to subtract the due date from the work remaining. I am going to divide the due date and the work remaining. Why? See, I'll give you an example. 5 days of work remaining, 5 days due. 5 by 5 is 1. So the critical ratio is 1. If the critical ratio is 1, which means both are equal, number of days and number of due days is the same. But when you come here, you do a 5 divided by 2. What is 5 divided by 2? 2.5. You know what that means? I have enough time to finish this job 2.5 times. So with the days that I have, I can do this job twice and then do it another half time also. While this job, the ratio worked out to be 1, which means I can finish this one whole job. But when you come here, it is 7 divided by 5. Sorry, 5 divided by 7. What is 5 divided by 7? Well, 5 divided by 7 is 0.71. You know what that means? Even if I start today, I will only be able to do 71% of the job. So, the lesser the ratio, the more important it is to start the job now. The more the ratio, the later you can push it. So, I am actually taking a slack, but I am taking a slack by dividing the two. The criteria remains the same. Here, you will never have a negative. But the criteria remains the same, and that is the least critical ratio should be processed first. So let's start taking a critical ratio. It is the due date, which is 5, divided by the number of days that the work is remaining. So number 1, 5 divided by 2 is 2.5. Very good ratio. 5 divided by 4. is 1.25. Still a good ratio. It means I can finish this job once, and then if I start again, I will be able to do another quarter of the job also. 5 divided by 7, bad, is 0.71. A ratio which is less than 1, which means I won't be able to finish the job once also. 5 divided by 6. 5 divided by 6 is 0.8333, which means if I start today, I will only be able to finish 83% of the job by the end of the week, which is the due days. 5 divided by 5, 1. And then you have 5 divided by 3 is 1.666. What does that mean? Well, if I start today, I can do this job once. And then if I again start after doing it once, I will again be able to do the same job 60%. So I will be able to do the job more than once basically. So according to the critical ratio rule, again, the least critical ratio should be processed first. Whose critical ratio is the most critical? Well, this 0.71 is the least, which means that will be processed first, C. After that is D. After that is E. After that is B. After that is 1.666, which is F, and last is A. If you notice, according to the critical ratio rule and the LS rule, both have given you the same answer. Anyway, let's look at their solution. Their solution is critical ratio. Critical ratio for the first job is 5/2, which is 2.5. Second job is 1.25, 0.71, 0.831 and 0.67. Then they start sequencing. They've drawn a table with the job and the critical ratio, so that you know that least critical ratio is put first. 3. So the answer is CDEBFA. Let me check if that is the same. CDEBFA. Perfect. That is question number 3. The next we come to is question number 4. Now, what is question number 4? Up until now, we were assuming that the jobs have to go through only one machine. For example, the Xeroxing example that I give you, when you want to Xerox your Aadhaar card or whatever, or book, it only has to process through one machine. No, you don't need two machines to process. But there can be jobs that need more time to, more number of machines to process. I don't want to give you like a fantastic example, but I'm going to give you a basic example. Everybody's washed utensils at home. Yes, and now that the lockdown is going on, I'm definitely sure that work at home has been distributed amongst the variety of people at home. So everybody has a job now. You wake up, you have to do this. No matter when you do it, I don't really care. It has to be done. So even in my house here, the job is distributed. I am the Bartan wala Admi. My dad is the pocha, mother is the cooking, and I have a cousin who lives with us here in Kolhapur. He is the putting the clothes in the washing machine and then putting them out to dry. So everybody has their jobs and everybody knows when to do them. Nobody needs to be told when to do what. So the process of washing utensils. Imagine not one person, two people are washing utensils. So if two people are washing utensils, you can distribute the job into two parts. One part is scrubbing and cleaning them. The other part is washing them under water or rinsing them off. So now every utensil has to go through two processes, not just one. It has to go through the first process and then go to the second process. Or then another example is making rotis or making chapatis. If two people are doing this job, one person is rolling them out and the other person is roasting them. Now what happens when two people are doing the job is, every job might take different times on both the processes. And when that happens, you need to make sure that you are well coordinated. Because if you are not well coordinated, what is going to happen is there are going to be times where if I am the second person who is rinsing the utensils, You are not done washing, so I'm just standing there. So I'm done washing one utensil and then I'm waiting for the second one. And then the second one, till the time I rinse the second one, you've put two other utensils there. So now you are piling on. So suddenly I start moving fast and then I realize, array, now again I have to wait. And you want to avoid doing this. And if you want to avoid doing this, there is a process in which it is done. And I will explain to you how this process helps once I have showed you the entire process. Let's read the question. In a factory, there are 6 jobs to perform, each of which should go through 2 machines A and B. So I have an order for 6 jobs. These 6 jobs have to go through 2 machines A and B. So let me give you an example. I am making PVC pipes. One machine makes the pipe and the other machine has to cut the pipe and it has to it has to put my label on it or put my branding on it. So every pipe that is made once comes out of machine A, it has to go into machine B. Fine. So I have 6 orders. All 6 orders have to be processed through both the machines A and B. In the order AB, very important. It is very important for me to know who is working first and who is working second. So here they say that A is working first and B is working second. The processing time in hours for the jobs are given below. You are required to determine the sequence for performing the jobs that would minimize the total lapsed time T. What is the value of T? I'll tell you everything. I'll tell you what lapse time is and everything. This is those kind of a questions where once I do the question, I will be able to tell you better what everything is and how this makes the process better. So again, they have given you the jobs 1 to 6. They have given you the 2 machines that process these jobs 1 to 6. And they have also given you the timings of the jobs on that particular machine. So again, let me do one thing. Let me quickly write down the question so that we can continue. I have the question ready. Let's begin with the solution. So these are the 6 jobs that you've given me and you want me to sequence them so that they reduced the total lapsed time. I don't even know what lapsed time is. So total lapsed is completely different idea. Okay, I will give you the sequence. For this sequence, you have to follow a process. And that is what I'm going to do. I'm going to write down the process one step at a time. Correct? Out of whatever I'm going to write, some things are important, some things are not important to be written. But for me, so that you understand it and then whenever you want to refer it, you will understand it. It is very important. So I'm going to start writing down here. The first thing that you are going to do is draw blank spots according to number of jobs. So step 1 is draw blank spots according to the number of jobs you have. I have 6 jobs, then I will have 6 blanks. 2, 3, 4, 5, 6. Done? That is step 1. Step 2. Who works first and who works second? You ask, who is working first? Well, they just told you that whatever job has to go to A first and then B, in that order, A and then B. Okay, so according to me, the order is A and B. Correct? So now remember that if the order is A and B, humor me and understand. A goes in first and B goes in last. What does that mean? 1, 2, 3, 4, 5, 6. A will go in from here and B will go in from here. So what does that mean? I will tell you. Just pay attention. If you've done math in the 11th and the 12th, you've done this under a chapter called assignment problems. Job sequencing is done there. We've done 2 machine and 3 machine sequencing also. Anyway, coming back. If you want to sequence jobs that have to go through 2 processes, you have to follow certain rules. Rule number 1. Draw 6 blanks. Done. After find out who works first and who works second. Well, they said A, B in that order. So A works first, B works second. So A goes in first, B goes in second. Fine. Step number 4, and this is from where the sequencing begins. And that is identify the job with the least processing time. Now, people will ask, sir, but where? I'll tell you. Doesn't matter for A or B. So, identify the job with the least processing time. Well, the job with the least processing time, but for whom? For A or B? And it doesn't matter. Any job that has the least processing time anywhere. Or I like to say it, what is the least number in all of this? Sorry. Well, the least number in all of this is 1. Okay. Now listen to what I'm saying carefully. This 1 is for job 6. Then job 6 will enter first into the queue. So, identify the job with the least processing time. Doesn't matter for A or for B. Correct? So, I have picked up 6. A is 8 and B is 1. And that is why I picked up 6. Correct? Now, job 6 will enter first into the sequence, but from where? What is this least time for? B, no. B enters from the back. So I will say since 1 is the processing time for job 6. Job 6 will enter first into the sequence. Correct? But since the least processing time is for machine B, 6 will enter from the back. Let me repeat this again. Pick up the least processing time from the entire lot. What is the least processing time? 1. This 1 is for whom? Job 6. Then job 6 will go first into the sequence. But sir, from where? Front or back? Well, the least time for 6 is for machine B or machine A? It's for machine B. Then machine B enters from the back. Then 1, 2, 3, 4, 5, 6. This is from where 6 will enter. Because the least time for 6 was for B. Done? Remove 6 from your table because 6 is in the sequence now. So I don't need to look at 6 again. Let's continue. Yes. After 6, go to the next least processing time. Well, the next least processing time is 2. Who is this processing time for? It is for job 3. Okay. Then 3 will enter next. So, I'm not writing the entire thing down anymore. I hope you understood it. So, 3, A, B, A is 2, B is 6. So 3 will enter, but from where? Well, 3 will enter, but the least time is for A, which means it will enter from the front. So the answer is A, 1, 2, 3, 4, 5, 6. B, 6 is here, 3 is here. Done. Cancel the 3 out. After that, go to the next least processing time. What is the next least processing time? 3 is the next least. It is for 1. So 1 will enter. But where will 1 enter from? The front or the back? Well, because that processing time 3 is for B, 1 will enter from the back. So I will have 6 here, I will have 3 here, and 1 will enter from the back here. Fine. Let's go back again. 3, 1, 6 already put. Let's cancel 1 because 1 has also entered the table. Let's go to the next least. Well, now in the next least, there is a 4 and a 4. So, who will enter? 2 will enter and 5 will enter. But don't worry. This 4 is for A, so 2 will enter from the front. And this 4 is for B, so 5 will enter from the back. But sir, what if this 4 was for both of A? Then it's okay, write it anyhow. Write 2 first and then 5, or 5 first and then 2, doesn't matter. Your final answer will be the same. But here it doesn't matter because this is for A and this is for B. So this job will enter from the front and this job will enter from the back. So I have 2 entering from the front and 5 entering from the back. So 2 entering from the front and 5 entering from the back. That leaves us with one and only one job, and that is 4 and 3, 2, 4, 5, 1, 6 is your answer. This is the sequence in which the jobs will be processed. I will repeat the same thing. I am leaving this for like a few seconds so that if you want to, you can pause and then write down whatever you have to. And I will do the question again for you, but this time quicker. So like I said, I'm going to do the entire question again or the sequencing again, but this time slightly faster. Step 1, draw 6 blanks because there are 6 jobs. How are you going to process the jobs? Well, A first and then B. So A enters from the front and B enters from the back. Fantastic. Step number 1. Pick up the least time in the entire matrix. The least time is 1. Who is this 1 for? The 1 is for 6. If the 1 is for 6, which means job 6 enters first into the sequence. This least time is for B, which means 6 will enter from the back. Done? After that, what is the next least time? The next least time is 2. This 2 is for job 3. So next in the sequence will go job 3. Job 3 has a least time on A. So then job 3 will enter from the front. The next least is for job 1. That least is for B, which means job 1 will enter but from the back. The next least is 4, but there is a 4 in 2 places. But the 4 here is for A and the 4 here is for B. So that's okay. This job will enter from the front while this job will enter from the back. At the same time, sir, what if this and this was 4? Well, then you can enter both from the front and you can write it anyhow. You can write it as 2, 5 or 5, 2 is okay. The final answer will remain the same. But here it doesn't matter because this 4 is for job A, so 2 will enter from the front and machine A, and this 4 is for machine B, so 5 will enter from the back. That leaves us with one and only one job, which is 4, and that's your answer. Your sequence is 3, 2, 4, 5, 1, 6. Like I said, I'm quickly going to read through what they have written and let's verify. So, The least of all timings given in the table is for job 6 on machine B. So perform job 6 in the end, in the last. It is last in the sequence. Now delete this job from the given data. Of all the timings, now the minimum is for job 3 on machine A. So do the job 3 first. After deleting job 3, the smallest is 3 hours on job 1 for machine B. Thus perform 1 at the end before 6. Having assigned job 1, we observe that the smallest value 4 hours is shared by job 2 on machine A and by 5 on machine B. So perform job 2 first and job 5 in the end. Now the only job remaining is job 4. It shall be assigned to the only place in the sequence. The resultant sequence of the job is therefore 3, 2, 4. Now they've put these by mistake, the blanks in between. 3, 2, 4, 5, 1, 6. So 3, 2, 4, 5, 1, 6. Let's check if my sequence and their sequence is the same. Three, 2, 4, 5, 1, 6. Yes. 3, 2, 4, 5, 1, 6. My sequence and their sequence is the same. Fantastic. Let's start continuing with the question. Now once the sequence is decided, I'm cleaning this because I'm going to require values from this table. So what is going to happen? What is going to happen is job 3 is going to be processed first. How is it going to be processed? See, job 3 will go to machine A. It will take 2 hours on machine A. And once machine A is done, it will go to machine B. So there is a sequence that is going to flow, which is job will go into machine A, come out of machine A, go into machine B, come out of machine B. And that is why I am going to draw a table with the job going into A, coming out of A, going into B and coming out of B to calculate the timings. So let me quickly do that. I have my table ready. Let's begin. What is the sequence in which I am going to perform these jobs? Well, I am going to perform these jobs as 3 first, then 2, then 4, then 5, then 1 and then 6. So every job will go into A first, come out and go into B. So this is how it's going to work. You come into the store, what time? 9 a.m. Then I will start at 9 a.m. At 9 a.m. you will pick up job 3. But what if you come in at 10 a.m. Then I'll have to write 10 a.m. Then let's forget the confusion. I'm just going to say 0. You came in at the 0th time frame and then you add whatever time you come in, you will get the rest of the timings. So I'm writing 0. So on the 0th time frame, you picked up job 3. Now job 3 on machine A takes 2 hours. So if you picked up 3, it took 2 hours to process it. 0 plus 2 is 2. After 2 hours, job 3 on machine A was done. Now what? Now B will pick it up. When will B pick it up? B will pick up the job at 2 because it got done from A at 2 and B can only process after A. So it will pick up the job after A is done, and 3 on B takes 6 hours to process. So after 2 hours, it will take 6 more hours and I will be done at 8 hours. Okay, let's come back to job 2. When will I pick up job 2? Well, job 3 got done at 8 hours. No. Job 3 got done at 8 hours, that I agree. But A was done in 2 hours. Then why do I need to consider 8 hours? A was done after 2 hours. No. Then once A is done and A hands over the job to B, A can pick up the next job. Correct. So when will A pick up 2? A will pick up 2 at 2 hours. And how long does 2 take on A? Well, it takes 4 hours. Then after 2, 4 hours is going to be 6 hours. Now after that, job 2 will be picked up by B. When can B pick up job 2? Well, B can pick up job 2 at 6 hours. 1 minute. It can't pick up. Imagine 0 means 12 o'clock. So at 12 o'clock you pick up job 3. At 2 o'clock you are done. At 2 o'clock B picks up, takes 6 hours, and at 8 o'clock B is done. Now see, A was done at 2 o'clock. So A picked up the next job at 2 o'clock, took 4 hours and finished by 6. Is B free at 6? No. B is going to be free from the previous job at 8. But sir, A didn't have to wait for anyone. That's correct. Why will A have to wait? A is working first. A doesn't have to wait for anyone. B has to wait for A to finish. And after A finishes, B starts. I have to keep checking if B can pick up the job or not, because a lot of times what is going to happen is B has not finished the previous job. How can you give him the next job? So can I say one thing before all this begins? A doesn't have to wait for anyone, no? Then do one thing. Don't do this both together. Do this one at a time. Do this only for A and then start doing it only for B. That will be better. Okay, I'll do that. Let's start only for A. So we are doing the processing only for A. Can we do it? Yes. Because see, A can quickly start working. A doesn't have to wait for anyone else. Fantastic. A picks up 3 at the 0th minute. 3 on A takes 2 hours. 0 plus 2 is 2. Done. 3 on A is done. Then machine A picks up 2. When can it pick up? At 2 hours, because it's done doing the first job. 2 on A takes 4 hours. 2 plus 4 is 6 hours. 2 on A is done. Then it picks up 4. When will it pick up 4? It will pick up 4 at 6 hours. 4 on A takes 5 hours. 6 plus 5 is 11. When will it pick up the next job 5? It will pick up the next job 5 at 11. 5 on A takes 9 hours. 11 plus 9 is, it will be done by 20 hours. When will we pick up the next job? Well, the next job will be picked up at 20, because it just got done at 5 at 20. 1 on A takes 7 hours, days, minutes, whatever it is. 20 plus 7 is 27. A will pick up 6 at 27 hours. 6 on A takes 8 hours. 27 plus 8 is 35 hours. That's done the processing of A. We now come to B. Now what we'll do? When will B start? When A is done. A is done at 2, then B can start at 2. B on 3. B on 3 takes 6 hours. So 2 plus 6 is 8. It will be done at 8 hours. When will B pick up the next job? Now it's very important to check two things. Number one, B will pick up A. B will pick up the next job when A is done. When is A done? At 6 hours. But you also have to check, is B free at that point? No. B is going to be free at 8. Is that correct? Which means that B will pick up the job at 8 and not at 6. I hope this is understood to everyone. A finishes processing 2 at 6, but at 6 B is still doing the third job. So B can only pick up 2 not at 6 but after it is done with 3, which is at 8. B for job 2 takes 8 hours. 8 plus 8 is 16. B got done at 16. Is the next job available at 16? Yes. It has been available since 11. When am I picking it up? Now at 16. 4 on B takes 6 hours. 16 plus 6 is 22 hours. Is the next job available at 22? Yes. It has been available since 20. Which means the next job can be picked up at 22 hours. Job 5 on B takes 4 hours. 22 plus 4 is 26. B got done at 26. B will pick up the next job at 26? No. Because the next job is not available at 26. It is going to be available at 27. So what B will do is, B will wait and then pick up the job at 27. I will make a note here that there is a 1 hour waiting. See, if the job waits, I don't have a problem. But if the person working on it waits, it's a problem because I'm paying that person. The more he or she waits, the more money I waste. And that is why I don't document the job waiting. I document the machine waiting. Because here B got done with the fifth job at 26 hours, days, minutes, and it realized that 1 is going to be available only and only at 27 hours, days or minutes. It has to wait till 27 and then pick up the job. 1 on B takes 3 hours. 27 plus 3 is 30. Is the next job available at 30? No. It is going to be available at 35. So I wait till 35. I make a note here that there is a 5-hour waiting. At 35, I pick up 6. 35 on 6 takes 1 hour. 35 plus 6 is 36. And this 36 is your total lapsed time. What do you mean by total lapsed time? It's basically the total time required for both the machines to finish processing all the jobs. I'm going to quickly repeat this again, but a little faster right below here, and then we are going to draw a few conclusions from this table. So let me get both the tables ready here. Let's begin. Jobs 1 to 6, machine A timing, machine B timing, the sequence that I decided some time ago, and that was 3 2 4 5 1 6. So sequence was 3 2 4 5 1 6. Let's begin. I will first do for A because A doesn't have to wait for anyone. B has to wait for A. So I will first finish A and then start doing it for B. Let's start then. 3 will be picked up at the 0th time. 3 on A takes 2 hours. So 0 plus 2 is 2. Done? Done. Then what will I do? I will pick up 2. When can I pick up 2? 2 is going to be available at 2. At 2, I will start job 2 and it will take 4 hours, days, week for me. 2 plus 4 is 6. At 6, I will pick up 4. 4 on A takes 5 hours. 6 plus 5 is 11. At 11, I will pick up 5. 5 on A takes 9 hours. 11 plus 9 is 20. At 20, I will pick up 1. 1 on A takes 7 hours. 20 plus 1 is 27. At 27, I will pick up 6. 6 on A takes 8 hours. 8 plus 27 is 35. Done? Now I start for B, but I need to be careful because I need to check. Even though B is free to pick up the job, is the job available? You will only pick up the job if it is available when you are available. Now the B is free, hasn't started work. So it can pick up job 3 at 2. B picks up job 3 at 2, takes 6 hours to process. 2 plus 6 is 8. Now you will ask, at 8, is the job available? Yes, the job has been done since 6. 6 o'clock, you are free at 8 o'clock, which means the job is available. Pick it up at 8. The job had to wait. There's nothing like job waiting. If I have to wait, it's a problem. Job has to wait, nobody cares. The job 2 is picked up by B at 8. So 2 on B takes 8 hours. 8 plus 8 is 16. Is the next job available at 16? Yes, it's been available since 11. Then you can pick it up at 16. Pick the next job up at 16. 4 on B takes 6 hours. 16 plus 6 is 22. If I'm correct, yes, 22. Is the next job available at 22? Yes, it's been available since 20. It is waiting for 2 hours. That's okay. The job can wait. It's like asking the patient was waiting. Nobody cares. Doctor cannot be sitting idle. Patients can wait. 22. Job 5 on B takes 4 hours. 22 plus 4 is 26. So the doctor is free at 26. Has the patient arrived? No. The patient is going to arrive at 27. So now the doctor doesn't have a choice but waiting up till 27, which is basically 1 hour. At 27, picks up 1. 1 on B takes 3 hours. 27 plus 3 is 30. Is the next job available at 30? It's going to be available at 35. Oh, then I'll wait up till 35. When I wait up till 35, it takes 5 hours waiting or 5 hours stay sitting idle. I pick up 6 at 35. 6 on B takes 1 hour. 35 plus 1 is 36. And that's your answer. So what they expect out of you from the solution is, number 1, the sequence. Give them a few steps in which how you are entering the sequence. And number 2, this table. Now, like I told you, we are going to draw a few inferences from the table. Now, the table drawn above has a little more space. So, I am going to draw inferences here. Inference number 1. Total lapsed time is 36 hours. Is the data given in hours? Yes. So it is 36 hours. In 36 hours, everybody will be done. Now we are going to calculate something called as a waiting time or something called as an idle time. This idle time will be for machine A and for machine B. Arey sir, machine A was never idle. Machine A was working back to back because it didn't have to wait. B was idle. No. Both the machines will always have one fixed idle time. And that is, when did the work end? At 36 hours. When did A's work end? At 35 hours. Then do you agree for that 1 hour A had to wait? And that is why A has 1 idle time. Similarly, B will have 1 idle time always at the top. How come? When did the work start? At 0. When did B start working? At 2. So then can I say B was idle for the first 2 hours? And these two standard idles will always be there for every question, no matter what the question is. They will always have an idle time for A, 1 idle time for A and 1 idle time for B. And for A, that's the only 1 idle time. There will be no other idle time. B might have other idle times, and we evidently see it does. B has another idle time of 1 hour and another idle time of 5 hours. So the total idle, if you check, will be 5, 6, 7, 8. 8 hours for B and 1 hour for A. So this I have drawn for you. You are going to write idle times. Idle time for A 1 hour, idle time for B 2 plus 1 plus 5, which is a total of 8 hours. So total idle, if you ask me, 8 plus 1, which is 9 hours. So the total lapse time is 36 hours, in which there is a 9-hour idle shared between both A and B. So let me repeat this. After doing this, we are going to do we are analyzing the timings. So the first thing you analyze is, when does all the work get done? 36 hours. After this, so the lapse time is 36 hours. After this, the idle times for A and B. A and B will always have one idle time. Always. A will have only 1, B will have at least 1. A's idle time is, A finished, but the total work finished after that. The difference between them is A's idle time. And B's idle time is, A started, B didn't start. So B started after A. So the time that A started and B started, the difference is the idle for B. Along with that, did B wait anywhere? Yes, there are 2 places, once for 1 hour and once for 5 hours. So the total is 8. What I'm going to do is, I'm going to show you the same, but in a slightly different way, or I'm going to teach you how to verify if this is correct. How? Go back to your table. Check how much time does machine A require to do all the jobs. So it is 7 plus 4 plus 2 plus 5 plus 9 plus 8 is a total of 35 hours is the total job timing required on A. What about B? 3 plus 8 plus 6 plus 6 plus 4 plus 1 is a total of 28 hours. Fantastic. 1 minute. You are telling me that A's job is only for 38 hours. Then why are you working for 36 hours? Obviously, no. Then there is a 1 hour idle that A has to do. So, the idle times can also be found by total lapsed minus total time on A, which is basically 36 minus 35, which is 1 hour, which is correct, the idle time for A. And now I have to verify for B. B's total work is only 28 hours, but you are making the poor thing work for 36 hours. How many extra hours is he putting in even when not required? 36 minus 28. 8 hours extra, obviously. So that 8 hours, he or she is going to be idle, or that machine is going to be idle. So it is going to be 36 minus the total time on B, which is 28, which is 8 hours. So the total idle is 1 hour and 8 hour, which is a total of 9 hours. Technically, when they used to ask these questions in the 12th standard, they expected 3 important things. Number 1, total lapsed, idle of A, idle of B, and total idle. Here they are not really specified. They've only found you the lapse time, but this is my analysis. I know I've written it up because I wanted to write everything in one paper. On the board, I can keep writing to show you, but here I cannot. That is why I've written everything on one page. Please understand. I'm going to quickly, very fast, run through the entire solution. And that is, whenever a job has to go through two machines. Well, in this case, it has to go through machine A and then through machine B. The first thing that we have to do is we have to decide a sequence. How will you do that? 6 jobs, draw 6 blanks. If the processing is AB, then A enters from the front, B enters from the back. Pick up the least timing. That least timing for whatever job it is, that job will enter either from the front or from the back, depending on that timing is for A or for B. If it is for A, enter it from the front. If it is for B, enter it from the back. According to that, we decide the final sequence. Once you have this final sequence, we are now going to find the total lapse time. How? Write down the jobs, write down machine A, machine B, in, out, in, out. Write down the sequence in which you have decided the job sequencing. Start at the 0th time, pick up the first job, which is job 3. Check how long does it take on A, add that to the 0, and then continue in a cumulative fashion till you finish all the jobs. After doing that, come to the next machine. But now remember, until and unless the job is finished by A, B cannot pick it up. If it is already available, then pick it up. But if it is not available, wait. And there are times where I have to wait twice. This waiting can be mentioned here so that you can verify, or what you can do is, it's simple, find the total time required on each machine and then take a difference with the lapsed time. That will also give you the same waiting. If both tally, which means this calculation is correct. Let's quickly look at the solution from the material. So, number 1, they created a sequence which was done. Number 2, job machine A in out, machine B in out. Total lapse is 36. So they have written everything verbally. As shown in the table, the first job 3 starts at, it's not lime, it's time 0 on machine A and is over by time 2. When it passes to machine B to be worked until 8, the job 2 starts on machine A at time 2 as the machine is free at that time. It is completed by 6 and then has to wait for 2 hours for it to be processed to B, and then starting at time 8 when the machine is free, similarly the various jobs assigned to the machines and the in-out times are obtained. Now my problem is, fine, the in-out times are obtained, but the analysis, what you've done, you've written, agreed, but what have you analyzed out of it is not written. So what I would expect if I would ask this question in the exam is, at the end of it, I would expect, I wouldn't want to know what this is. What I would expect is, what is the total lapse time? Number 1. Number 2, what are the intermediate waitings? So lapse time, total idle and independent idles. Now, why did we sequence in the format that we have sequenced? Well, for a reason. If you don't sequence in this format, or if you sequence in any other format, this total lifetime will increase. I guarantee you that. No other sequence will give you a lesser lapse time. There might be a sequence that might give you the same lapse time, but no other sequence will give you a lesser lapse time. This method of sequencing gives you the least lapsed time and hence the least waiting. Any other sequence you try, you will get more lapsed and more waiting. This process reduces the lapse and then hence reduces the waiting. That is it. That is question number 4. The last question on the sheet. Before I start with the next question, which is one last question, and I don't know why it's put because it has too many concepts together. And like I said, there's just one question they don't even ask. I will try and explain what it means as much as I can, which again also nobody will ask. Eventually the solution of the question will matter. So what I have done is I have just put one example and I've done different things with that example. I want everybody to pay attention. So, the question says that, here, this is an example, correct? And what all is given to you? The job is given, the processing days is given, and the due date is given. Now, technically, if you don't give me the slack remaining and the critical ratio, which is the slack and the critical ratio, these two I can anyway find. It doesn't matter. These two can be found by me. It's not that you have to give it to me. But now that you've given it, it's okay. What do you want me to do? So what I'm going to do is, I'm going to sequence them according to first come first serve, shortest processing time, earliest due date, least slack time, and critical ratio. These are the ways in which I'm going to sequence them, and after doing that, I'm going to find a few things. Number one, something called as an average flow time or a mean flow time. And I'm going to calculate something called as an average lateness. When and as and how I continue, I will tell you what that means. So let's come to the question. If this is the question, the first thing I'm going to do is sequence the jobs according to first come first serve basis. Now see, according to first come first serve basis, I will process the jobs as and how they have come. So my sequence will remain A, B, C, D, E. And this is my sequence A, B, C, D, E. Okay. Now the rest, which is all this, is calculated later. All of this. All this is calculated afterwards. Correct. So let's start with one at a time. This is your jobs A, B, C, D. These are the processing times. I have written 20, 30, 10, 16, 18 as and how they gave me the processing times. And now I'm going to do a little bit of analyzing of these times. And that is number one, I'm going to calculate flow. Now what is flow? You did this when you were doing those two machine job sequencings. You did this, we did this. It's just that we did that for two machines there. Here there is no two machines, there is just one job, and I was assuming because not mentioned it's going through only one machine. So I'm going to do what I did there, but not for two machines, just for one. So job 1 or A can be picked up at 0th time frame. It takes 20 days. 0 plus 20 is 20. At 20, I pick up job B. 20 plus 30 is 50. At 50, I pick up job C. 50 plus 10 is 60. At 60, I pick up job D. 60 plus 10 is 76. At 76, I pick up job E. 76 plus 18 is 94. And wasn't the total timings of the jobs also 94? So that tallies then. Total time required was going to be 94. So on the 94th day, minute, hour, whatever it is, my job is done. Correct? Now, what we are going to do is, we are going to calculate how late is a particular job if I sequence in this manner. So step 1 is going back and writing down what were their due dates. So I go back and I copy all my due dates here, 30, 50, 25, 80 and 60. And I come back. Now let's calculate how late is a particular job. Job A got done on the 20th day. The due date is in 30 days. Is it late? It's early. 1 minute. I'm not asking you earliness. Nobody gives you an award for doing something early. If you do it late, you have to incur a loss or a compensation of some kind or a penalty. Early, nobody really cares. You gave me a due date, give it to me then or before that, no problem. After that is a problem. So is the job late? No, it's 10 days early. The next job B has been done on the 50th day. Correct? When was the due? 50th day. Fantastic. Then it's exactly on the same time, so it is not late. Job C is done on the 60th day, but it was due on the 25th day. The job is late by 35 days. Job D is done on the 76th day. It was due 80 days later. Fine, it's 4 days early, so there is no lateness. The lateness is 0. Job E is done on the 94th day. The due date was 60, which means you are a 34-day late. The total lateness is 69 days. And when I divide the total lateness of 69 days amongst the 5 jobs, the average lateness becomes 13.5. I similarly find something else, and that is, do you see these flow times that I've done, that in what sequence will they flow? Which means I know which job starts on which day and ends on which day. So if you ask me job D, I will say job D starts on day 61 and ends on day 76. So these are the flow times. I have also taken a total of the flow times, which is 300. And the mean flow is 60. What have I done? The total flow is divided amongst 5 people and I get an answer of 60. Now I want you to understand a few things. Number 1, no matter, I repeat, no matter how you sequence the jobs, the total number of days will be 94. No matter how you sequence it, that 94 is never going to change, no matter which job you do when. But yes, the total flow might change and the total lateness might change. So what I'm going to do now is I'm going to sequence the jobs with different criteria, and as in how I do them, I'm going to check 2 things. What is the total flow and what is the total lateness, and then take an average and tell you the mean flow and the mean lateness. This was the first, which is first come first serve basis. Let's come to the next one, and that is shortest processing time first. If I sequence according to SPT, I realize that my sequence is C, D, E, A, B, which is 10, 16, 9, 18, 20, 30 and 94. Like I told you, the total will be 94, and everything, the last flow time will always be 94. That is never changing. So again, you calculate the flow, pick up C on the 0th day, take 10 days. So 10 plus 16 is 26, 26 plus 18 is 44, 44 plus 20 is 64, 64 plus 30 is 94. Now I start calculating the lateness. It got done on the 10th day, but it was due in 25 days, not late. Done on the 26th day, due in 80 days, so not late. 4460, not late. 6430, late. By how many days? 34 days. 9450, late. By how many days? 44 days. Total lateness, 78 days. Average lateness, 15.6. Total flow, 238. Average flow, 47.6. Is that right? Let's continue. What if I sequence these jobs according to the least slack? Correct? So if I sequence them according to the slack time, whoever has the least slack. So if I go back in the table where the slacks are given, these are the slacks. So I will say A should be processed first, then C, then B, then E and then D. So is it the same way? Yes, it is A, C, B, E and D. When I do that, I again find the flow, I again find the lateness. I look at the mean flow, it is 56.4 and the average lateness is 9.4. I continue and I do the same with the critical ratio rule. With the critical ratio rule, I start sequencing them with the least critical ratio. Once I do that, sequencing them with the least critical ratio, I get this as the flow time. I get an average flow of 60.4. And I get this as the lateness, and I get the average lateness as 13.4. So let me come back and tell you what have we done. What we've done is for every job, we have sequenced the jobs with different sequencing criterias, and we have found two things majorly. Total flow, total lateness, and from the total flow and mean lateness. Let's start comparing. Now when you start comparing, oh, there is one more, earliest due date. You have the flow, you have the lateness, EDD. Now we start comparing. When you start comparing, according to FCFS, the mean flow is 60 and the lateness is 13.9. Now when you compare all the mean flow times, you realize that the SPT flow time is the least. So when you sequence according to the shortest processing time, you get the least mean flow time. The same time, when you look at lateness, when you sequence according to EDD, you get the least lateness, and that is 8.4. So in a question, if they randomly tell me that this is the jobs, these are the timings, these are the due dates, and these are the, the timings and the due dates, and they say that sequence this so that the mean flow time is the least, then I'm not going to check with every method. I know that mean flow time is the least when sequencing is done with SPT, which is the shortest processing time first. And if you ask me lateness, then lateness is the least. The lesser the late, the better it is. Then lateness is the least if I sequence according to EDD, which is the earliest due date. So if in any question they ask me to minimize mean flow time, I know sequence it by SPT, don't do trial and error. If they ask me to minimize the lateness, then I will always sequence it with EDD. What do you mean by lateness? Well, obviously lateness is very easy. How late is going to be the job? So the lesser the lateness, it's better. But sir, I don't understand what this mean flow time is. Well, mean flow time is how long on an average does a job be in the system. Like I'll try and simplify this at my level as much as I can. Let me give you an example. Suppose what you're doing is you are frying puris or you are frying something. Now you are not frying it in batches, you are frying it one at a time as and how it is ready. So you put the first puri in, it's still frying. 2 minutes in, you put the second puri in, it's still frying. 2 minutes in, you put the third puri in, it's still frying. So now you start pulling out the puris one at a time as and how they get done. So puri 1 will be done the first, so you pull it out. Then you put in puri 4, then you remove puri 2, and this process is going on. My question to you is, if the gas finishes now, if the gas is over and there is no more heat, then can I say all the puris that are there in the pan are going to be wasted because the oil will cool down quickly and the puris will not fry properly. My question is, how many puris have you wasted? Well, then you count how many puris have you wasted. Imagine that now, but with jobs. When jobs are processing, while one job is reaching the end, the second job is reached the start. Or the job number 1 is at the end, job number 2 is somewhere in the middle of the processing, and job number 3 has entered the processing. So at a given time, there are more than one jobs in the system. The lesser the average flow time of these jobs, the lesser number of jobs in the system and the lesser chances of those jobs being wasted if my system shuts down right now. And that is what you mean by mean flow time. Nobody is going to ever ask you. Nobody will ever ask you what mean flow time is and what its implications or repercussions are. So if any of this is taxing, all I want you to remember is just two things. Number one, when they ask you to sequence a job so that the mean flow time is the least, always remember we will sequence according to SPT, which is the shortest processing time. And if they ask you to reduce the lateness, you will say that process the jobs according to their earliest due date, which is EDD. If this much is understood, let's go on to the question that I want to do. Let's come to the question now that I said I wanted to, or like one last question left on that concept. So the question says, the processing times in hours for 5 jobs of a single machine scheduling is given. Find the optimal sequence which will minimize the mean flow time. Do you realize what they did? They said find the optimal sequence which will minimize the mean flow time. So right now I want you to write in a bold statement and remember that. Sequencing according to SPT brackets shortest processing time gives you the least mean flow time. And number 2, sequencing according to EDD, which is earliest due date, gives you the least lateness, average mean lateness or average lateness. Fine. You want me to minimize the mean flow time? Then I know that I have to sequence according to shortest processing time first. Determine the sequence which will minimize the weighed mean flow time and also find the mean flow time. Okay, so you want me to find the mean flow time and then you've given me weights and you want me to find the mean weighed flow time also. Okay, so one thing at a time. Let me write down the question. So step 1 is going to be, I have written down the question so that I don't have to go back to my PDF. And now I am going to start the solution one at a time. Step 1 is going to be, what do you want me to do? You want me to minimize the mean flow time. I'm not going to find all different sequences and then tell you where the mean flow time is the least. I'm directly going to mention that mean flow time is minimum. Obviously, I'm writing here to save space. I expect you to write this below. Mean flow time is minimum when jobs are sequenced according to SPT, that is shortest processing time first. Fine, let's decide the sequence then. Job, time. What you can do is you can separately find the sequence here and then, so sequence according to SPT, job and time. So job number 2 is the least time, which is 8. Then comes job number 3 with 10. Then comes job number 5 with 16. Then comes job number 4 with 28. And then comes job number 1 with 30. So this is going to be my sequence. My sequence is going to be job 2, job 3, job 5, job 4 and job 1. In the first part, they don't mention anything about the weights. So I'm going to do the question without the weights. 8, 10, 16, 28 and 30. What I'm going to do is I'm going to calculate a flow time. What do you mean by flow time? If I pick up job 2 at the 0th time, on the 8th day it will be done. On the 9th day I can pick up job 3. So 8 plus 10 is 18 days. This will be done. On the 19th day morning, I will pick up job 5. 18 plus 6 is going to be 18 plus 16 is going to be 34. On the 34th day, this will be done. 34 plus 28. 34 plus 28 is 62. 62th day, this will be done. Plus 30 is going to be 92. Now, just to be sure, check if the total jobs require 92 days. And that is 8 plus 10 plus 16 plus 28 plus 30. Does it require 92 days? Yes, the total is 92. So that is correct. You have the flow. We have to calculate something called as the mean flow. Now what is mean flow? Mean flow is sum of all the flow times divided by the total number of jobs. So sum of all the flow times is going to be 8 plus 18 plus 34 plus 62 plus 92 is 214 divided by 5 jobs. This total flow time is for 5 jobs in total. 214 divided by 5 jobs is 42.8. This is the mean flow time if you sequence according to SPT, that is shortest processing time first, and I guarantee you that no matter how you sequence it, and if you find the flow time and if you find the mean flow, your mean flow will always be greater than 42.8. No other sequencing will reduce the mean flow time from 42.8, and I've showed it to you. This is it. This is the end of the first part of the question. Let's look at the solution in the material. Do they have the same solution? So, this solution. First, arrange the jobs as per the shortest processing time. Why? Why do you want me to arrange the jobs according to the shortest processing time? You haven't mentioned. Why? Because the jobs will have the least flow time. So therefore, the job sequence that minimizes the mean flow time is 2, 3, 5, 6, 5, 4, 1, which is also our sequence 2, 3, 5, 4, 1. Now after that, they have done nothing. They have written horizontally, I have drawn vertically. It's up to you what you want to do. Jobs 2, 3, 5, 4, 1. Processing times and the flow 92. Total, so the mean flow time is going to be the sum of all the flows divided by 5. Sum of all the 4 flows is 214 divided by 5 is 42.8. That's your answer. The mean flow time of these jobs is 42.8 hours. That's it. That is where I said the first part of the question comes to an end. The second part is the part, I don't know why they've put it, extremely painful. Let's come back to the question. Now in the question, they have given you weights, correct? And they have asked you to determine the sequence that will minimize the weighed mean flow time. See, now I know one thing. Flow time can be reduced or minimized only by sequencing according to SPT. But now they have given us weights. So the weights have to be taken into consideration? Yes. I want to stop this question right here and elaborate a little bit on weights. What do you mean by weights? Where do we use them? How do we use them? So let this be. Let's do it here. What do you mean by weights? Where do we use them? Why do we use them? Suppose I have to declare an award, and the award is the Student of the Year award. So for this award, obviously there is going to be cycling in gym shorts and there's going to be swimming. No, not really. My Student of the Year award is a very normal award. I'm going to decide it on 3 criteria. Criteria number 1, what is your attendance? Criteria number 2, what is your marks throughout the year? So this year, if I'm giving this to this year, I'm going to consider all students. So if this is happening when I'm in the 8th standard, I will be judged on the basis of my marks in the 7th standard. So I'm basically going to say what your marks are. And number 3, I'm going to declare this on the basis of if you are in part of any extra curriculars. These are the 3 criteria. So we start with student A, student B, student A, student B. Two contenders have been listed, and student A has an attendance of 75%, has marks 65%, and has participated in 10 curricular activities. So I gave him 10 points. Student B has an attendance of only 60%, has marks of 50, but has had a total of 50 certificates. Now, if I want to decide which amongst the two students gets the award, I will take a total. What is the total? 75 plus 65 plus 10 is a total of 150. And the total here is, sorry, this goes to 160. Let me reduce something. 1 minute. Let me reduce this to not 50 but 30. He has only, oh no, that means he's failed. Can't do that. Fine. Now let it be, for this example, let it be 30. Student B is 60 plus 30 is 90 plus 50 is 140. Evidently, you see, student A should get an award. But what if this award was declared? Let's say Sachin Tendulkar is from my school. He's my school's alumni. He's the ex-student from my school. And he has declared this award to that one student who is good in extracurriculars. Then it's unfair that you are considering everyone. But then my sister sits Sachin Tendulkar down and tells him, my principal sits Sachin Tendulkar down and tells him that, listen, if we declare an award only on the basis of extracurriculars, all students will stop studying and stop coming to school and only attend extracurricular activities. But then you will say, Ari, this is unfair. This kid only has 10 marks in extracurriculars. My award is specifically for extracurriculars. So that puts both of them in a dilemma. Should we consider all the marks or should we not? According to the principal, we should consider all this. According to Sachin Tendulkar, we should not. We should only consider the extracurricular marks. Obviously, if he is good at extracurriculars, he will be bad at academics. He will not have very good attendance. That's obvious. So they decide somewhere in the middle. What they say, let's consider all 3 marks, but let's give all marks a weightage. Attendance is important, but not as important. So I'm giving it a weight of 2. Being good in academics is important, but not very important. So I'm giving it a weight of 3. And this award is specifically for academic extracurriculars. So I'm giving extracurriculars the most weight, and that is a weight of 5. What does that mean? Now when I consider A's marks, I will not consider A's marks directly. I will consider A's marks with the weightage. So attendance has been given a double weightage. So if your attendance is 75, double it and make it 75 into 2, 150. Because that much more is its importance. And for marks, if it's more weightage, more the importance. 60 will double and become 120. 65 will triple and become 65 into 3 is 195. 30 into 3 is 90. 5 into 10 is 50. 50 into 5 is 250. And now take a total. The total for A will be 150 plus 195 plus 50, and that is 395. And the total for B will be 250 plus 90 plus 120 is a total of 460. And now take an average. Now initially this total was only for these 3 marks. But now what is happening? I am considering these marks twice, these marks 3 times and these marks 5 times. So I am not adding a total of 3 marks only. I am adding 2, 3 and 5, a total of 10 marks. So when I take an average, 395 by 10 is 39.5 and 460 by 10 is 46. Isn't B's average better, or isn't B's weighed average better? Yes. And that is why I give the award to B, so that both are happy. Sachin Tendulkar is happy because I have given the reason why this award is given the most weightage, and my principal is also happy because I am writing down, I'm giving every other aspect also importance. I'm not completely eradicating it. Marks are considered, attendance is also considered. And this is what you mean by a weighted average. So what do you mean by weights? What do you mean by weights is whatever has more importance gets more weight, whatever has less importance gets less weight. What we are going to do is exactly the same, but with a small difference. And that is, let's come back to the question. Let me now quickly write down the weights that were given. So the weights that were given in the question is according to which job is more important and according to which job is less important. Let me mention the weights. I have written down the jobs, I have written down their timings, and I have written down their weights. Now, what does a weight do? A weight gives something more importance. But you tell me one thing. According to shortest processing time, less is more important. Is that right? If I multiply, so if you are telling me that 16 is most important because it has a weight of 3. When I multiply 16 by 3, it will become 16 into 3 is 48 if I am correct. Yes. And if I multiply 10 by 1, it will become 10. What is more important? Is 10 more important or 48 more important? Obviously 10. So by multiplying, have you increased its importance or decreased its importance? Well, I have decreased the importance because according to time, more is not good, less is good. So the difference here is, here when I apply weights, I will not multiply. Here to increase importance, I have to reduce time, and that is why I am going to divide the time by the weights. 30 by 1 is 30, 8 by 2 is 4, 10 by 1 is 10, 28 by 2 is 14, and 16 by 3 is 5.33. And now I will sequence according to this weighed time. But always remember that when we apply weights, we multiply the weights to increase its importance. In time, lesser is more important, and that is why when we apply weights in time, we don't multiply, we divide. And now I will sequence according to minimum weighed time. How? Job and time divided by the weight. What is the least of this? The least weighed time is for 2. The next least is 5. The next least is 3. The next least is 4. And the next least is 1, which is 30. Let me repeat this. I have to sequence the jobs, but giving them weights. What does weight mean? More the weight is more important. So normally I multiply the weight to increase its importance. When it's marks, multiply, increase the importance. When it's money, multiply, more money, more important. But it's time, less is more important. And that is why to give something more preference, I won't multiply the weight, I will divide by the weight. Once you've divided by the weight, done. Now forget the weights. Your sequence is decided. Now everything will happen according to this sequence. Forget what the weights were. And start writing down job and your new sequence, which is 2, 5, 3, 4 and 1. Let's write down the timings. The time for job 2 is 8, not 4 anymore. That 4 was only to help you sequence. Once the sequence is done, you forget the weighed times. The weighed times are not the actual times. The wait times are times taken to increase or decrease importance. Once you are done, forget the wait times. 2 is 8, then 5 is 16, then 3 is 10, then 4 is 28, and 1 is 30. Find the flow time. 8, 16 plus 8 is 24. 24 plus 10 is 34. 34 plus 28 is 62. 62 plus 30 is 92. Well, see, that is always going to remain 92. That is never going to change. Now I take a total flow. No. This is the second thing that changes. Usually I would take a second flow. But now I am going to write down the weights. What are the weights? Job 2 had a weight of 2. Job 5 had a weight of 3. Job 3 had a weight of 1. Job 4 had a weight of 2. And job 1 had a weight of 1. Now multiply the flow by the weights. 8 2s are 16. 24 into 3 is 72. 34 into 1 is 34. 62 into 2 is 124. And 92 into 1 is 92. Take a total. 16 plus 72 plus 34 plus 124 plus 92. And the answer is 338. If you now take an average or a mean weighed flow time, it is going to be the sum of all the flows into the weights divided by the total of the weights. Sum of all the flows into the weights is 338 divided by the total of the weights is 2 plus 3 is 5. 2 plus 1 is 3 plus 1 is 4. The answer is 9. So the answer is 338 divided by 9, which is 37.55. And that is your mean weighed flow time. I'm quickly going to repeat this. They have given you weights in the question and they are asking you to minimize the mean weighed flow time. So to minimize the mean flow time, I have to process according to SPT, which is the shortest processing time. But if weights are given, the importance of every job changes and I first have to increase and decrease importance according to the weights. How will I do that? Time. If I want to increase importance, should be reduced. And that is why I divide the time by the weight and I get a new weighed time. And according to this new weight time, I create a sequence. That new sequence that I have created, I will now use this sequence to calculate the flow. And I come back to the original timings. I forget these weight timings. So job, time, flow. Now this flow will be multiplied by the weights because it's weighed flow time. These flows will be divided by the total of the weights. And the answer is 37.5. Let's look at the solution from the material. So this is the question. This is the first part of the question. For the second part, we start from here. Number 1. The weights given are as follows. So jobs, times and their weights. Weighed processing time is processing time divided by the weights. Okay. The weighed processing time represents. So the weighed processing times are 3, 4, 10, 14, 5.31. Thus arranging the jobs in the increasing order of their weights processing time we have. So we have arranged the jobs in the increasing or an ascending order of the weighed flow times. Once that is done, you forget the weighed flow times. Write down the jobs. Now they've done the table horizontally, I've done it vertically. Write down the jobs, write down the processing times, find the flow, write the weights, multiply the flow by the weights and take an average of the sum of the weighed flow divided by the total weights, which is 37.55. So that their answer is 37.55 and so is my answer. So the answer of both is going to be 37.455. This is my solution. I have finished it off in this so that you have everything in one. You can pause the video and check it. This is it. With this, sequencing or job processing is done. As always, with every topic, we check how many marks the topic was asked in the exam. So we go back to question papers and check which paper the topic has been asked how many times and for how many marks. Let's come to the new topic, which is sequencing. Correct? June 17, June 18, December 18, and so on. Let's start with question papers. So, skip the MCQs, the true or false, directly come to question 2 onwards. So 2AB no, 3AB no, 4A no, 4B no, 5 no, AB no. So can I say that paper sequencing has not been asked? So let me make a note of that question paper not been asked, which is the June 17. Let's come to the December 17. So 2A, let me also do one thing. Let me mark the questions that are done. 2B was done. 3A, no. 3B, no. 4A, yes. Look at this. Look at the question. They've asked it to you for 10 marks. कौन पूछता है this for 10 marks? The below table shows the time remaining, number of days until due date, and the work remaining, number of days of work for 5 jobs, which are assigned letters A to E as they arrived at the shop. Sequence these jobs according to priorities, namely FCFS, EDD, LS, SPT, LPT. That's it. That is all they are asking out of you for 10 marks. Every method is given 2 marks. And this is where I said, remember I said that if for 10 marks this is what is asked, then try to paint it as much as you can and write it. Write down FCFS is first come first served basis. In this method, we process jobs as and how they arrive at the shop. Therefore, the sequence will be the same in the sequence that they arrive in the shop. A, B, C, D, E, and then that is the sequence. Number 2, EDD. EDD is sequencing jobs according to earliest due date. Therefore, these jobs will be processed according to whichever job has the earliest due date. Do that and so on. All this only for 10 marks. Make sure that you have a solution for this behind the same chapter. So that write down the question paper, page, question number, and finish it off right now. So that you have the solution of all question papers also ready. So let me make a note of that. And the note of that will be that one question has been asked for 10 marks. 4A. Let me check if anywhere else. I don't think so. Yes, that's it. This was also done yesterday under productivity. So yes, that's it. 4AB, 5AB. No. So can I say one question? 4A asked for 10 marks. So this is going to be December 17. One question. I'm writing very small, you won't be able to see, but I'm saying what I'm writing. FCFS, SPT, just write in short. 10 marks. Correct? Let's move on to the next paper. Let's come to the June 18 paper. Move past through the objectives. 2A. 2A, no. 2B, no. 3A, no. 3B, no. 4A, no. 4B, no. 5A, yes. The following jobs have to be shipped a week from now, which is 5 days. Sequence the jobs according to the least slack rule and the critical ratio rule. That's it. They've asked you this for 8 marks. Wow. So, finish this question off. Right behind this itself so that you have the running solution ready. Let me make a note of it. In the June 18 question paper, you had one question which is critical ratio and least slack, and that was asked for 8 marks. Let's continue. That was June 18. Let's come to December 18. December 18, question 2A was done under forecasting. 2B was done under forecasting. 3AB no. 4A no. 4B also no. That's a simulation question. 5A no. 5B also no. So not asked in this question paper at all. Let's come to the next question paper, and that is the June 19 question paper. June 19 question 2A no. 2B is done under let me mark that, under facility planning. 3AB no. 4 is assignment problem. 4B is a queuing theory. 5A, yes, same question that they asked some time ago. They've again asked it for 10 marks. FCFS, EDD, LS, LPT, SPT, that's it. That is all. For a total of, you notice, 2 into 5 which is 10 which is for A, and then 6 which is for B. So they've asked you the question for 10 marks. So, let me make a note of that. In this question paper, which is the June 19 paper, one question, again, FC, FS, SPT and all of that for 10 marks. Let's come to the last question paper now, which is the December 19 question paper. Skip past the objectives. Let's come to the subjectives or the descriptive questions. 2B was done. 3B was also done. 4A is not that question. 4B is also not that. 5A no. 5B no. That's it. We are done then. No question asked. So whenever it is asked for a heavy 10 or an 8 marks. If not asked, not. And that is obvious if not, because see, there are going to be a total of 1, 2, 3, 4, 5 questions that are going to be in descriptive. That I'll discuss with you once the syllabus is done. Now, according to me, there are roughly around, I think according to my breakdown, there are roughly 12 to 15 topics. Even if you say 12 topics, they can't ask you every topic, every paper. Even if there are 15 topics, they can ask one topic every 3 papers. So that is why, if you notice, not asked thrice in 6 papers, 6 attempts. 3 times asked, 3 times not asked. But when it is asked for a lot of heavy marks. That's it. This was the 5th topic, according to me 6, which is forecasting, location, facility, aggregate, capacity. 7 actually. Forecasting, location, facility, aggregate, capacity, productivity and sequencing. But according to the dependence wise or how they are related to each other, 5 topics. This is it. The lecture, the video has gone to be a little more than the 1.5 hour which you all get in standard, but that's okay. You can do this at one go, nothing very major. This is it. This is sequencing done. Thank you very much, and I will see you with a new topic in the next session. Bye.